Welcome Algebra 2 students to the homework out video, page 148. These numbers right here. Let's go ahead and get started with the problems. Now, I almost did not give you numbers 7 through 12 because they're matching, but I got thinking, it's real important for these students to learn to use common sense, and also to learn shortcuts, not to be lazy, but to save you time. So I said to myself, Mr. Teacher Self, it would be good for these students to learn to look at some linear inequality systems and to match them with graphs without doing all the work. So that's what we're going to do here. Okay, little by little, we're going to cross these off and use process of elimination. Okay, so what I'm looking for is any distinct characteristic. Instead of graphing all 6 of these, I'm looking for distinct, characteristics that are different than other inequality systems. So, x is greater than -3. Do I see that anywhere? I see one here, but not here. So number 7, I see x is greater than -3. X is greater than -3. Notice one's going to be solid. Do you see that? And one's going to be dotted. Do you see that? So let's go through and circle the ones that have a vertical line going up and down through 3. This one does. This one does not. It would be right here. This one does not. See, this one does here. My fault, students. Sorry. This one does not. This one does right here. And boy, these are really hard to see, aren't they? Here's the y-axis. Okay, I'm back. That's it, guys. So this one and this one both have a line going through x. X equals 3. Do you see that, guys? Look, no other inequality up here has x is greater than or less than to -3. This one has +3, but not -3. Do you see that? So I know the answers to 7 and 11 have to be A or C. Just like that, I know that. Now, this one here has the dotted line. There's no equal sign here. This one here has the equal sign. It's going to be the solid line. So look at this one that I circled. I have a solid line going right through here at x equals 3. So I know right away that letter A has got to be this one here, number 11. Now, notice this one over here, students, has a dotted line going through x equals 3. Okay, so I know this one here has to be C. So there we go. I'm going to cross this one off, cross this one off, cross this one off, and cross this one. That was a lot faster than graphing both of those, okay? Now let's look for some more distinct characteristics. How about y and 2? I only see one inequality that says y and a -2. Don't see one here. I see a +2, but not a -2. Not one here, not one here. So only one of these graphs will have a horizontal line going through -2. This one does. This one does not. This one does not. This one does not. This one does not. This is the only one right here that has a horizontal line going through -2. So process of elimination, that has to be B, which is your answer. Okay, so now we're done with this, and we're done with this, just like that. Now let's look for other distinct characteristics. Here's one down here. Y is less than or equal to 2. Nowhere else do I see a y and a 2 all by themselves in one inequality. So I'm looking for a horizontal line going through +2. Well, this one has a horizontal line going through +2. That must be it. This one doesn't. This one doesn't. So I'm assuming that number 12 is letter D. Yes, it is. So now I can cross this one off and cross off letter D. Wow, I'm moving right along, guys. Now, what are the differences between these right here? Well, I've got X and a 3. I see no X and a 3 up here. So I'm looking for a vertical line passing through 3. A vertical line passing through 3. This one has a vertical line right here passing through 3. This is your y-axis. See your y right here. This is your y. This is your y-axis. This is over 3. So guys, this has to be the answer, number 10, letter E. So there we go. The only one left is F. F has to go to number 9. Mr. Earhart, you went a little fast. We'll back it up and watch it again if you need to, but here's what I'm trying to show you guys. It's very good sometimes to work problems out, period. But other times it's okay to use shortcuts and common sense. You will be taking, or maybe you have already taken, the ACT test, or maybe some of you will choose to take the SAT test. It is so important to look for shortcuts and use things like this to help you work the problems quickly. I'm not very familiar with the SAT test, but I know the ACT has 60 problems that has to be done in 60 minutes. Okay, that's one problem per minute. You're going to need, some problems take 2 or 3, 4 minutes. So there are some problems you have to do like in 20 or 30 seconds very quickly. So it's okay to learn to use shortcuts like this. In fact, it's very good to do that. All right, moving on. Number 16, let's solve this inequality system. First of all, I have y is less than 4. Got it? It's going to be a dotted line, and I'm going to rewrite it for a second as y equals 4. Okay? Now, I'm going to quickly number this, call it number 1, and I'm going to draw a horizontal line because I just have one letter here through positive 4. There we go. So a dotted line going through there. And we're going to label that line number 1. Y is less than. We're going to shade downward before we're finished. Okay? Now let's change to the color black. We're going to color this number. We're going to call this number 2. Now we have x is greater than negative 4. Well, I'm going to rewrite that with the equal sign just to help me find my boundary. I'm looking for a vertical line because I have one variable, x. Remember, whenever you have one variable that's a y, your line will be a horizontal line. It crosses across the y-axis. If I have an inequality with only an x in it, it's a vertical line crossing across the x-axis. In this case, it'll cross the x-axis at negative 4. So right here, and it will be a dotted line. There we go. There we go. We'll call that line number 2. Now, let's call this line number 3 right here. Y is greater than x. Now that has 2 variables, does it not? Come on, students, think it has a y and an x. So it's not going to be a horizontal line. It's not going to be a vertical line. It's going to be a slanted line. I'm going to rewrite this with an equal sign. And now I'm going to use quickly a table of values. That'll be so fast. Put a 0 in for x, get out a 0 for y. Put a 1 in for x, get a 1 out for y. Put a 2 in for x, get out a 2. Pretty simple. So 0, 0, 1, 1, 2, 2. Now it will be a dotted line, so make sure you use a dotted line when you connect those 3 points. And look at that, students. There we go. That's line number 3. Now, are you listening? With a horizontal line, you know to shade up or down just by looking at the inequality. With a vertical line, you know whether to shade to the right or left just by looking at the inequality. In fact, we never did that on line 2, did we? I apologize. X is greater than negative 4. Do you see it here? X is greater than negative 4. That's another reason you should number your inequality graphs because it helps you go back if you're confused or made a mistake somewhere. You can very easily go back and line up or connect the correct line with the correct inequality. So I should have put arrows going to the right. We're going to shade greater than negative 4. X is greater than negative 4. Now this is a slanted line. Your green line is slanted, so we must test the point. Notice you're going through 0, 0. So pick a point way off like slide it down, we're shading this way. See this green arrow, slide it down the line, we're shading this way. So it looks like to me, we're going to have a triangular shaped region. We're staying to the right of the black line, below the red line, but above the green line. So there is my answer. All of the ordered pairs that fall in this shaded area would be the solution to this linear inequality system. Any points that lie on the dotted lines are not part of the solution. Okay guys, let's move on. Number 17. I'm going to call this equation or inequality number 1. I'm going to rewrite it with an equal sign. Y equals -5. That's going to be a horizontal line, and it's going to be dotted. Okay, so here we go. I'll go to -5 on the y-axis right here, and it's going to be dotted. I knew it was a horizontal line because there were no x's in the inequality, just a y only, and we'll call this line number 1. Y is greater than -5, so we shade upward. Pretty simple. Moving on to the next inequality. We'll call this inequality number 2. X is less than or equal to 2. Now that's a single variable inequality with no y, just an x. So we know we're going to have a vertical line. We know it's going to be a solid line because I have an equal sign right here. I'm going to rewrite it with an equal sign. X equals 2. So we have a vertical line that crosses the x-axis at 2. Okay? And let me get a little help here from since I can't draw very well. There we go. And that's going to, we're going to shade to the left because it says x is less than negative or positive 2. So we'll shade this way, and we're going to call that line number 2. Now, let's go on to inequality number 3 here. And notice we have an x and a y. So for me, I know it's going to be slanted. I know it's going to be solid. And I know I've got to use a technique other than just a vertical or solid line. For me, guys, when y is by itself and it's like x plus 2, I don't know. Some of you like the slope-intercept method, which is totally fine. I just put a 0 and get out of 2. Put in a 1, get out of 3. Put in a 2, get out of 4. That's just pretty fast to me. So 0, 2, 1, 3, 2, 4. It will be a solid line. And so we'll do the best we can to keep it pretty straight, I hope. There it is. Now, because it's a slanted line, the only way to know where to shade is to test a point. Does 0, 0 fall on my green line? By the way, let's label that number 3. No, it does not. So where the y is, I'm going to substitute 0. Where the x is, I'm going to substitute 0. 0 is less than 2. That's true. 0 is less than 2, so this point here is true. So I'm going to shade downward. So come on, guys. I know I'm going to shade this way on the red line. I'm going to shade up on the black line and down on the green line. We have almost a carbon copy of the last problem that we just did, okay? We have a bounded region. It's enclosed on all sides. And there's our shaded area right there. So any ordered pair that falls in the shaded area is a solution to our linear inequality system. Any point that lies on the black line will not be part of your solution. It's dotted. However, any point that lies on the green line and the red line will be part of your solution because they are solid lines. Okay? Alright, moving on. Number 18, here we go. First of all, I'm going to start off with inequality number 1. Y is less than -1. Now it's going to be a solid line, okay? And it's going to be horizontal because I have a y only, no x. Y equals -1. So I go to the y-axis, -1. And I'm going to put a horizontal line right there. And y is less than -1, so I'm going to shade downward, and we'll call that line number 1. Now, line number 2, or inequality number so I know it's going to be a vertical line. It does have an equal sign, but ditto mark's going to be solid, and it's going to cross the x-axis at 2. So there's my point right there, and we'll have a vertical line going through 2. Now, label this line number 2. X is less than 2. X is less than 2, so we're going to shade to the left. To the left. Now when I get to my third inequality, I notice it has 2 variables, x and y, so it's going to be slanted. It's going to be solid because of my equal sign here, and I'm very quickly going to use a table of values. Just like the last time, put in a 0, get out a 2, put in a 1, get out a 3, put in a 2, get out a 4. Just like that. I put a 0 in for x, then a 1 in for x, then a 2 in for x. Okay? Now I'm going a little fast on these, but guys, this is stuff you should have mastered by now, okay? I mean, really should have. So my first order pair is 0, 2. My second order pair is 1, 3. And my third order pair is 2, 4. Over 2, up 4. Now it's going to be a solid line. And notice the green line does not pass through 0, 0 right here, so I can test that point to see where to shade. So where the y is, I put a 0. Where the x is, I put a 0. 0's less than 2. 0's less than 2. Okay, well that is definitely correct. I'm going to shade down toward this point right here. It's true. So I'm going to shade down. So this one's, I think this one's going to be an unbounded region. Let's see. We got to stay below the black line this way, but below the green line here to the left of the red line. So we got to stay below the green line. Then we hit this point right here. We got to stay below the black line, right guys? If you go up here, then you just went above the green line. We can't do that. And if you go up here, you just went above the black line. We can't do that, okay? So we got to stay below the black line. Then we hit the red line. We got to stay to the left of the red line. So there we go. So this shaded region is called unbounded because it continues on and on, going downward and to the left. As this line continues, this will continue. As the red line goes down, this shaded area here will continue. Okay, so all of the answers that satisfy this inequality system would lie in the shaded area or on all of your solid lines. I hope this is making sense, guys. Okay, I really do. Alright, moving on. Number 19. Now, inequality number 1 has two variables, x and y. Do you see that? So I'm going to do this a little differently. I'm going to go like this. Okay, now, I'm going to go ahead and use the slope-intercept method. So my y-intercept is -3, my constant term. My slope is the x coefficient, 2 over 1. This is I'm going to put an I for rise. If I put an R for rise and an R for run, that's not going to help. So I'm going to put an I for my rise, a U for my run, rise, run. And I don't like that. It's going to confuse students. So sometimes I have really bad ideas, and that was just one of them. Let's put the word rise and run. Alright, so -3 is my y-intercept, so we'll put a point here. And we're going to rise 2 and run 1. So rise 2, run 1. Now it's going to be a solid line. Okay, so we'll continue this. There we go. Now that's line number 1. And now we're going to test 0, 0. So where the y is, I will put a 0. Where the x is here, I'll put a 0. Excuse me. 2 times 0 is 0. 0 minus 3 is -3. So 0 is greater than -3. That's true. On a number line, 0 is further to the right than -3. So 0, 0 is true. I'm going to shade toward 0, 0. Okay, now let's go ahead and take a look at the second inequality. We'll call that number 2. And here we go. Notice y is all by itself. So once again, I have an x and a y. It's going to be a slanted line. It's going to be dotted. It's going to be slanted. It's going to be dotted. And I'm going to rewrite it like this. Y equals negative 5x, negative 8. Now, I'm going to go ahead and say that my y-intercept is negative 8. I know this because y is all by itself. When y is all by itself, then I know what the slope is and the y-intercept is, as long as it's a linear equation or inequality, and all of these are linear. Now my y-intercept is negative 8. That's right down here. And then my slope is negative 5 over 1. Now, I'm going to put the negative sign on the bottom. Do you know why I'm doing that? If I left it with a 5, I'd have to go down 5 and then positive 1 to the right, and I don't have room to do that. I'm running out of room, so you can put that negative sign wherever you want to, top or bottom. Just don't put it in both like that, because that makes the slope become positive, a negative over a negative. Okay, so my y-intercepts here, my rise number is 5, my run number is 1, negative 1. So rise 5 starting here. 1, 2, 3, 4, 5. Then run 1 to the left. To the left because it's a negative 1. It's going to be a dotted line, okay? So there's my dotted line. There it is. Now, I'm going to test 0, 0, because 0, 0 does not lie on the red line. So where the y is, I'm going to put a 0. Where the x is, I'm going to put a 0. 5 times 0 is 0, 0 minus 8 is negative 8. 0 is greater than negative 8. That's true. So we're going to shade toward 0, 0. So I've got to stay to the right of the black line going this way, or to the left of the black line, excuse me. I've got to stay to the right of the red line. So it looks like to me, I'm going to stay to the right of the red line until I hit this point right here, and then I've got to stay to the left of the black line. If I were to continue down like this, then I go below the black line. I can't do that, okay? And if I were to continue going down the black line like this, I just went below the red line. You cannot do that. So I've got to stay in this shaded area here. So once again, we have an unbounded region, okay? Unbounded region. And the solution to this linear inequality system would be all the points that lie in this area here, and also the points that lie on the solid lines, not the dotted lines, but the solid lines. Okay, 2 more of these to go, and then we will be finished, okay? Alright, number 20. Now, once again, guys, they're being kind of nice to us, giving us y all by itself like this, okay? In the top, I'm going to do this one here, table of values, and this one here, number 2. I'm going to do it slope-intercept method. So I look at my first inequality, I say to myself, okay, self, it has 2 variables, so I know it's going to be slanted. There's an equal sign right here, so I know it's going to be solid. I know I'm going to use my table of values. So I can do this in my head so quickly. Put in a 0, a 1, and a 2. Put a 0 in for x. 0 plus 3 is 3. Put a 1 in for x. 1 plus 3 is 4. Put a 2 in for x. 2 plus 3 is 5. So I'll go to 0, 3, 1, 4, 2, 5. And there's my solid line right there. Alright. There we go. Now, we're going to test 0, 0 to know where to shade. So where my y is right here, I'm going to put a 0. Where my x is right here, I'm going to put a 0. 0 is less than or equal to 0 plus 3 is 3. That's true. 0 is less than 3. So I'm going to shade downward toward this true point right here. 0, 0 is true. It is accurate. Now, let's move on to inequality number 2. On this one, I'm going to use the slope-intercept method. But first of all, I notice we have 2 variables, so I know it's going to be a slanted line. I know it's going to be a solid line because I have an equal sign right here with my inequality, or an inclusive inclusive symbol, however you want to say it. And y is all by itself. I'm going to go ahead and rewrite this with an equal sign to help me find my boundary. Alright, so I know my y-intercept is the constant term. My slope is the coefficient of the x. And I know that because y is all by itself. Now the last problem, we put the negative sign in the slope in the denominator. Let's put it up top this time just so we understand it can be done either way, okay? Just don't put it in both places, okay? Because that becomes a positive slope. Now, my y-intercept is -1, so I put a point here. My rise number is -1, my run number is 2. So if my rise is -1, then you go down. Your run is a positive 2, so go to the right. There we go. And that will be a solid line, okay? A solid line. And we'll call this line number 2, and I forgot to number my black line. It's my fault. Line number 1. Now let's put 0. Let's test 0, 0 for the red line, okay? So put a 0 in for y. -1/2 times 0 minus 1. 1/2 times 0 is 0. 0 minus 1 is -1. 0 is less than -1, excuse me. That is not true. 0 is greater than -1, not less than -1. So this point is false. So we're going to shade away from 0, 0, downward, okay? So where would this be? I mean, I'd like to shade below the red line here, but I can't because the black line is saying to shade down. So I've got to stay below the black line right here. When I hit this point right here, I've got to stay below the red line, okay? So there we go. So it'll be an unbounded region in all of this area here. Now I've not done this the entire time, but if some of you are struggling with finding the shading area, remember what I taught you. You can shade everywhere you're not supposed to shade. So the red line says to shade down. I'm going to shade upward. And the black line says to shade downward to the right, so I'm going to shade upward. And then the only place left is your answer. And that's going to be this area down here. Whatever it takes to get it right, okay? So your answer will be the shaded areas. The shaded area that we had in here. All of the ordered pairs that lie in the shaded area, plus all of the ordered pairs that lie on a solid line. All of those will be answers to your linear inequality system. One more of these, and then we're going to do something we've never done before, even in your notes. We're going to try to write some inequality systems on our own, okay? So here we go. Excuse me. Okay, number 24. We'll call that inequality number 1. Now I notice I have an x and a y, so it's going to be a slanted line. I have an equal sign, so it's going to be a solid line. And look what I got, students. I've got x then y then a -1. Well, that lends itself to the double intercept method so nicely. So where the x is, I'm going to put a 0. Where the y is, I'm going to put a 0. And here we go. 0 minus y is -y. 2 times 0 is 0. 0 minus y is -y equals a -1. If -y equals -1, then y equals 1. 2x minus 0 is 2x. Divide both sides by 2. X equals 1/2 or 0.5. So on the y-axis, I will go to +1. On the y-axis, I'll go to +1. On the y-axis, +1/2. Okay, and there we go. So let's go ahead and graph that line here pretty quickly. And here we go. Not perfect, but definitely good enough, okay? We'll call this line number 1. And now we got to test the 0, 0. So where the x is, I will substitute a 0. Where the y is, I will substitute a 0. times 0, 0, 0 minus 0, 0, 0 is less than -1. That's false. 0 is greater than -1. So this is false. So we're going to shade away from 0, 0. Okay? Now I've got to erase all of this, so if you need to take more time, back it up and watch that again, feel free to, okay? Alright, inequality number 2. Now I notice right away that I have two variables. I will have a slanted line. It has an equal sign, so it'll be a solid line. And now I see that I have an x and a y and then the number -8. So I have x negative 2y equals -8. So where the x is, I will substitute a 0. Where the y is, I will substitute a 0. And let's see what happens, okay? 0, -2y is -2y. Divide both sides by -2 and y equals 4. Now, 2 times 0 is 0, x minus 0 is x, x equals -8. So my x-intercept is -8 right over here. My y-intercept is positive 4, 1, 2, 3, 4 right here. Alright, so I'm going to connect those 2 points the best that I know how to. And there we go. Now, I've got to decide whether I'm going to shade up or down, left or right. So I'm going to test a 0, 0. So where my x is, I'm going to put a 0. Where my y is, I'm going to put a 0. See, 2 times 0 is 0, 0 minus 0 is 0, 0 is greater than -8. 0 is negative. 0 is greater than -8. That's true. So 0, 0 is a true point for the red line. I'm going to shade downward towards 0, 0. That's going to be line number 2. Alright. And then lastly, finally, line number 3. And we'll be cruising right along to our last two problems. Alright, now, notice I have one variable. Yay, I love these. One variable. So I know it's going to be it's y. There's no x. So I'm going to have a horizontal line. And it's going to be solid. It'll pass through the y-axis at 4. 1, 2, 3, 4 right here. It's going to be solid. Alright. So with that in mind, here's my horizontal line right there. Booyah. Perfect. Now it says y is less than 4, so I'm going to shade downward. Okay, now think about this. The black line and the red line are saying to shade. The black line is saying to shade this way right here, okay? Do you see that? However, I can't go above the red line, so I've got to stop at the red line, okay? So now I've got to shade this way. Now, the red line says to shade below it. So if I try to go like this, that's fine. But look what I just did. I went above the green line. Here's the green line right here. And I just went above it. I'm not allowed to. So when I start going like this, I have to stop. So at this point here, the graph turned. At this point here, it turned. And I'm staying below the green line. So I'm staying below the red line, below the green line, and to the right of the black line. And pretty much there we go, an unbounded region. Okay? An unbounded region. So the answer to this inequality system is all of the points that lie in the shaded area plus any of the points that lie on one of the solid lines within the shaded area. Okay? Okay, guys, let's continue on. Now they want us to write the inequality system. Well, 31's easy. 32's not so easy. Now, first of all, notice I have on the boundaries of my shaded area, I have horizontal lines and vertical lines. Do y'all see that okay? So I can write those inequalities pretty quickly. Stay with me. I'm going to use color coding here. See this black line right here? It's a horizontal line, correct? Do y'all see that? If I were to extend this horizontal line, it would cross the y-axis at where? Right there at 3. Okay, so now think about it. I have a horizontal line that's passing the y-axis at 3, so I know it's going to have y only, and it's going to have a 3. Now, is the blue area, the blue shaded area below the line or above the line? below it, so I know it's going to be less than 3. Is this line solid or dotted? Solid. So put a solid line here. Now, let's try another one. Let's try the other horizontal line. If I were to take this horizontal line here and extend it to the left, where would it cross the y-axis at? -5, right there. So I've got a horizontal line, so I know I'm going to have y only. It crosses the y-axis at -5, so at -5. I'm shading above the red line. Above the red line, excuse me. So if I'm shading above the red line, that's y is greater than. It's a solid line, so greater than or equal to. Now let's try the green line right here. This is a vertical line. It's a vertical line going through the x-axis at 1. So if it's vertical, I know I'm going to have an x only. It's crossing the x-axis at 1. I know I'll have a 1 over here. And the blue shading is to the right. So I would say x is greater than and equal to 1. Equal to because I have a solid line right here. And then last, my blue line might not show up very well. It's a vertical line going through 8. Now if it's a vertical line, I'm going to have x only. It's crossing the x-axis at 8, so I'll have an 8 over here. Notice I'm shading to the left. The blue shaded area is to the left. That would be x is less than. I would also have an equal sign because this line right here is a solid. Line. So there's your answer. You just went backwards. I gave you the graph of the linear inequality system, and you wrote the 4 inequalities. One more problem and we're finally done. Here we go. Okay, now let's knock out the 2 easy ones first. I've got a slanted line here, a slanted line here, okay? A horizontal line here and a horizontal line here. The horizontal lines are easy. This horizontal line right here is passing through the y-axis at where? 3, okay? So I know for the blue line I'm going to have a y, it's a horizontal line, and a 3. Now I'm shading below the line, so it'll be less than. It's a solid line, so equal. Now let's talk about the other horizontal line right here. It's crossing through the y-axis at -1. Do you see that? -1 right there. So it's a horizontal line, so I know I'll have a y only. I know I'll have a -1. And notice I'm shading above the green line, so y is greater than or equal to -1. Now let's talk about this slanted line here. Now this is going to be the tough one. We have an ordered pair here called 0, 3. And an ordered pair right here called -4, -1. Correct? Sure we do. So we're going to take remember how to write a linear equation. Guys, we've done this. How do you write a linear equation? Well, we have 2 points, so we want our good old formula called the point slope formula. There it is. Now, I did not have to use a formula for my horizontal lines because they're single variable equations or inequalities. I did not need to use a formula for my vertical lines back on 31 because horizontal and vertical lines are single variable problems, okay? However, I've got a slanted line here, so I'm going to have to do some work. I've got to find the equation of this line right here. Alright, so here we go. First I must find the slope so that I can substitute it in right here. So y minus y would be 3. 3 and -1, and my y is 3 minus -1. My x's are 0 and -4, so x minus x. 3 minus a -1 is 3 plus 1, 4. 0 minus a -4 is 4. 4 over 4 is 1. So my slope is 1. Now, which ordered pair do you want to use? Either one's fine. I like this one because there's a 0 in it. This is my x. This is my y. We just found my slope. My m is 1. So y minus my y, which is 3. X minus my x, which is 0. times x is x, 1 times 0 is 0. Now bring the 3 over and make it positive. Combine your like terms. Y equals x plus 3. Now we're doing really good. We found the linear equation of the line, but now we got to decide whether we're going to put in a less than or a greater than symbol. Well, let me ask you a question. Are you ready for this? Are you listening well? This slanted line is shading down this way toward what point that we love to test? 0, 0. So if I were to put a 0 in for y and a 0 in for x, what inequality symbol would I put here? 0 plus 3 is 3. Would I say 0's less than 3? Or would I say 0 is greater than 3? I would say greater than. I would say less than, correct? Sure I would. 0's less than 3. So that's the symbol I need to put here to give me out a true statement. Now why do I want a true statement for 0, 0? Because the line is being shaded toward 0, 0. If it wasn't being shaded toward 0, 0, then I would want to use an inequality that gave me out a false statement. But right here, I'm shading towards 0, 0. Okay? So I know I want 0, 0 to be a true statement. So I'm going to use this inequality right here. By the way, I put an equal sign here because the line is solid. So there we go. Moving on now. Next is my black color, and that'll be this line right here. And guys, we're doing the exact same thing all over again. It's a slanted line, is it not? Sure it is. So if it's a slanted line, I've got to use my good old formula. Well, first of all, here's my ordered pair right here. I'm going to use 5, negative 1. And my other ordered pair is 9, 3. So I have 2 points. If you're given 2 points, you want to use this model right here. The point slope model. Now, I have to find my slope because I have an m right here. Alright, so let's find my slope. Y minus y. That's negative 1 and 3, so y minus y. Then x minus x. My x's are 5 and 9, so 5, negative 9. Well, negative 1, you owe me 1, you owe me 3, you now owe me 4. You have $5, you owe 9, pay off your $5, and you still have a $4 debt. Negative over a negative is positive. 4 over 4 is 1, positive 1. So my slope, I'm going to put it right here. My slope is a positive 1, okay? Now, which point am I going to use? I'm going to use the one that doesn't have any negative numbers. So y minus y, my y is a 3. My m is a 1. And my x would be 9. X minus 9. Now take your 1 and multiply it through and let's simplify. Y minus 3 equals 1 times x is x. 1 times negative 9 is negative 9. Now bring your negative 3 over and make it a positive 3 so we can get y all by itself. Y equals x negative 6. Y equals x negative 6. You owe me $9. You pay off 3, you still owe $6. So there's my linear boundary. Pretty cool, okay? But I'm not done. Now I've got to decide what symbol, what inequality symbol to use. Well, let's do what I did before. Here's my nice little point I love to test, 0, 0. Am I shading? Is this blue area? Am I shading towards 0, 0 or not? Well, sure am. Here's the line. I'm shading this direction. In the blue area, it's towards 0, 0. So yes, I'm shading towards 0, 0. So when I put in 0, 0, I want to get out a true statement. So 0 minus 6 is negative 6. When I put the arrow this way or this way, is 0 greater than negative 6 or less than negative 6? Well, 0 is greater than negative 6. So put a greater sign here, a greater sign here, and that means we'll put a greater sign up here. Don't forget your equal sign also because the line is solid. Now, these have not been very easy, and I know I didn't teach you this, but I thought it'd be just good for you to go through and practice some of these and just see how you can do on them, okay? So, there we go. So, in the other problems, I gave you the inequalities, and you gave me the graph. In these last 2 problems here, I gave you the graph, and you gave me the inequality system. Alright, so there's your answer. I hope this homework help video has been a help to you. If you have any questions at all, don't hesitate to call.